In our kinematics unit, we get introduced to a quadratic equation. And I want to take a minute to break down the algebraic steps to solve for the various variables. So if you recall, the position function of an object that is accelerating looks something like this. Where an object is located, x final, is 1/2 at squared plus its initial velocity times time plus its initial position. Oftentimes this equation simplifies, and so I'm just going to say that we start with a zero velocity, and let's say we just start with at a location of 0 meters. Right? So now our equation is basically simplified into this equation, which says that where an object is located is 1/2 at squared. All right, so what do we do with this? So I'm going to look at this equation, and let's say we have 2 out of the 3 unknown variables. Again, when we're talking about variables, we're talking about things like the final position, the acceleration, and the time. 1/2 is just a constant in front. You can write it as a fraction 1/2. You can write it as 0.5. But if we have 2 of the other 3, we can always find the third. So let's look at a couple situations where we have other variables, and let's see how we would solve to find the missing one. So let's look at this equation. Let's look at our first example. Let's say that we have the time, and we'll say it's at 3 seconds. We have the acceleration, and let's say it's 4 meters per second squared. And we want to know, well, where will this object be located after that period of time, accelerating at 4 meters per second? So if you look at our equation above, you have 3 unknown variables, but they've given us 2, right? So like any algebra equation, we can substitute what those variables are with those numbers. So this equation becomes x final, the final position, is equal to 1/2. And multiplication, right? 1/2 is being multiplied by a. You could put a dot there in between. Oftentimes you'll see multiplication as parentheses. So a is 4, and t squared would be 3 squared. Right, so I can rewrite just by substituting those values in, and I'm not going to mess with the units right now. There are meters and seconds, so we should get an answer that comes out in meters, but I just want to really get a sense on how this equation is from an algebra standpoint. So when I substitute the values, I get 1/2 times 4 times 3 squared. And at this point, we're really just going to evaluate those numbers. But it's important to understand what we're really doing, right? Multiplication can happen in any order. I can multiply 4 times 1/2, then by 3 squared. That squared is only squaring the 3. It is not squaring the 4 or the 1/2. And if you want, we can evaluate the square first. Right? So one option would just be to evaluate the square, and 3 squared is now 9. So now I can simplify that right here. In my calculator, I can type in 1/2 times 4 times 9 to get a value. I could also just evaluate 1/2 times 4. Well, that's equal to 2. So I have 2 times 9, right? So the nice thing about algebra is we can do steps in any order. Some of you guys are going to see things that in your head you can evaluate more easily. But at the end of the day, I would get 18 meters as my final position if I started at 0, accelerating at 4 meters per second squared for 3 seconds. Some of the common mistakes we see are, again, squaring everything instead of just the 3. Not quite understanding what 1/2 is. I can rewrite this as 0.5. That's what 1/2 is, times 4 times 9. And that should give you the same value. In your calculator, you can type it all in as one step. If you've got a nice graphing calculator like this, right, we can just type in 0.5 times 4 times 9. Right? And sure enough, you get 18. So just want to show you, this is a real simple equation where we're plugging in the values for A and for T and just evaluating it. And again, we understand what it means to be squared. Remember, being squared, this is really saying 1/2 times 4 times 3 times 3, right? That's what 3 squared is. And again, 3 times 3 is what gives you the 9. So just to kind of recap some of those elements. Now, where this equation gets tricky is when you're actually solving for one of those other variables, right? In this problem, our variable we wanted, x final, was already isolated and by itself. So we really just had to plug in and chug. But what if we want to use that equation and we want to find what a is? All right, so let's reevaluate a second situation. We have the same function to describe the motion, 1/2 at squared, but this time the information we have is that the time it takes is 4 seconds. And instead of knowing a, we know that this object will be located at 16 meters after this acceleration. And what I want to find out is, what is a? All right, so now if you look at this equation, we have x final, we have t, and we don't have a. And with any algebra equation, if we're missing one piece, we can always solve for it. And so really we're just going to solve for a. Now some would actually solve for it before you plug in numbers and get a new equation for a. Right? But I'm going to plug in the numbers. I think most like to see the numbers in the problem. And as you get more practice, you might decide to do the algebraic steps before the numbers. But I'm going to sub in. I know that x final is 16. And that is equal to 1/2 times the unknown a times t squared. So that would be 4. And we square the 4. So what we do now is we need to isolate a. So a couple options here. I could multiply by 2, right? And then divide by 4 squared and get a. I can divide by 4 squared, then multiply by 2, or divide by 1/2. All these steps, it doesn't actually matter which way we approach it, right? In fact, I'm going to approach it 3 different ways. There we go. So my first way might be to take this equation, and I want to get rid of the 1/2. How do you get rid of 1/2? Well, you multiply the whole problem by 2. And if you do it to one side, you do it to the other. So that would eliminate that. 2 times 16 is now 32, is equal to, the 1/2 is gone, a times 4 squared. Right? And then I might say, well, what if I evaluate what 4 squared is? Well, 4 squared is 16. So now it's a times 16. And if I want to get the a by itself, I would divide by 16. And when I do that, I get that a is equal to 2, and that would be in meters per second squared. All right, so our answer should be 2 meters per second squared. But what if I wanted to do it in a different order? What if I take the same equation, 16 is equal to 1/2 a times 4 squared? All right, again, the square is only in the 4. What if I decide to evaluate the 4 squared first? All right, so now I have 16 is equal to 1/2 a times 4 squared is 16. Okay, right? Well, what if I want to divide by 16 right now? Well, let's divide the whole problem by 16. And when I do 16 over 16, on the left side, I actually get 1 is equal to 1/2 times a. And to get rid of the 1/2, I could multiply by 2. Hey, how about we just divide by 1/2? What is 1 divided by 1/2? Well, that would get rid of that. 1 divided by 1/2. How do we divide fractions? Well, when I divide a fraction, I'm really multiplying by its reciprocal, right? So really, I have this. And 1 times 2, lo and behold, we get a is equal to 2 meters per second squared. All right, so again, we did it in a different order this time, and we got 2 meters per second squared. What if, I'll do it one more time. Again, there's a lot of different ways you can solve these. Right, but let's take this same equation now and let's decide, well, 1/2 and 4 squared are just numbers being multiplied by a. Can I clean those up? Sure. Well, 16 is equal to 1/2 times, let's just rearrange it. 4 squared, again, is 16. So it'd be 1/2 times 16 times a. Right, I can multiply in any order. And 1/2 times 16 is just 8. So now I have 8 times a. Just by multiplying all the constant numbers that are multiplied by a. And to solve for a, I would just divide by 8 on both sides. That cancels. And 16 over 8, again, we have a is 2 meters per second squared. All right, so my point here with this whole mess is to show you that algebra is algebra, right? How the steps you take, the rules we follow, it's like grammar in English class. You can write the same statement in grammar a lot of different ways and still be grammatically correct as long as you follow basic rules of grammar, right? So this is how algebra works. All right, if I took this original equation, I can multiply both sides by 2, and I would have 2x final is equal to at squared. And I would then need to divide by t squared on both sides. And I would have an equation, a new equation, that a is equal to 2x final over t squared. right? I just solved that equation without any numbers, right? And now if I was going to do this multiple times, I can just use that equation over again. And lo and behold, 2 times x final, which is 16, divided by 4 squared. Well, 4 squared is 16. And hey, I get 2 meters per second squared. So I actually have an equation for A in terms of x final and t squared, right? This equation is the same as this equation. It's just been rearranged, right? So this is how we would solve an equation symbolically, right? With just the variables or the symbols. So again, how you do it doesn't matter as long as we follow the basic rules. Everything in this problem, there's no addition. So everything's multiplication. So anything we do, we got to either multiply or divide to isolate things. All right, last one here. Let's look at this same equation. X final is 1/2 at squared. But what if we want to know what t is? What if we know that x final is given to us as 32 meters? What if we know that a is 4 meters per second squared? And we want to know what is t. Oh, well now the unknown is t. I have x final, I have a, and I want to know what t is. How do we solve that equation? Right? Again, we could solve it algebraically without numbers. Right? If I wanted to get t squared by itself, it's being multiplied by a and by 1/2. I can multiply both sides by 2, and I get 2x final is equal to a times t squared. I could get t squared by itself by dividing both sides by a, and I get a new equation that says that, and I'll write t squared on the left, t squared is 2x final over a. And if I want to solve for a square, I solve it by taking the square root of both sides. And when I do that, I get an equation for t. T is equal to the square root of 2x final over a. This equation is the same equation as this, which is the same equation as our original equation. It has just been rearranged to solve for the variable t that we don't know. Right? So I can use this as a new formula, but when we understand algebra, we know that it's not really a new formula. This is still this equation. It's been rearranged using the rules of algebra to get the variable that we want. What most are going to do, however, rather than solving symbolically, is just plug in the numbers and see what happens. When I plug in these numbers into this equation, I get x final is 32, which is equal to 1/2 times a, which is 4, times t squared. And again, it's your choice on what you want to do next, right? I could multiply by 2, then divide by 4. I could divide by 4, then divide by 1/2. Either way, these values in front of t squared need to be removed from t squared. When it's written this way, I hope we recognize that I could just multiply 1/2 and 4. And when I do that, I get a new equation. 32 is equal to 1/2 times 4, which is 2t squared. I've just combined these two constants into one constant. And oh man, we got to get t by itself. Let's divide both sides by 2. And we divide both sides by 2. We now have a new equation that says, and I'll put the t squared on the left, t squared is equal to 16. And lo and behold, if I want to solve for something squared, I would take the square root, and I would get t is equal to, and here's a little catch, when you take the square root of a number, you actually get a positive and a negative value of 4. So t would be either positive or negative 4 seconds, right? If I take 4 seconds as a positive value and square it, I get 16. Negative 4 times negative 4 is 16. So both work. Oftentimes in science, we would take the positive because having negative time doesn't have a whole lot of meaning. But regardless now, we can take this and solve for t and get 4 seconds. Oh, by the way, if I took this equation and I said t is equal to the square root of 2 times x final is 32 and divide it by 4, right? Well, what do I get? I get the square root of 64 over 4, which is equal to the square root of 16. And lo and behold, I get t is plus or minus 4, right? So again, we get the same answer either way. So I thought this would be a good exercise as an algebra review with the typical equation we're going to see with kinematics, our quadratic function, 1/2 at squared plus v initial t plus x initial. And there are a lot of common algebra errors that I see. And the point I want to make is that there are basic rules to algebra and what we're allowed to do to an equation to keep it balanced. And the order we do it doesn't matter as long as we follow the rules. And all of us are going to see numbers slightly differently. We might decide one step is easier than another for ourselves. And you can decide to do it however you want to do it. You should get the same correct answer no matter how you choose to do it. So good luck as we continue to work on our algebra skills here in science. And hopefully this gives you a little bit more direction.